All right, here we go with the first notes in Unit 3. Unit 3 talks about graphing trig functions. In this unit, we're going to be graphing all of our trigonometric functions, such as sine, cosine, and tangent. But before we do any of that, we first have to discuss periodic functions because each of our trigonometric functions are periodic functions. So, what is a periodic function? Essentially, a periodic function is a function that repeats itself. It's defined over some certain interval, and is what we would call our period of our periodic function. And then every interval after that, it repeats itself exactly. Okay, so let's take a look at this example here on the left, function f. We see this wave pattern going on here. We have function values at 1, they go down to -3, they return to 1, down to -3, and back up to 1. And we would expect this pattern to continue. We've got this wave pattern. Even if we were to continue the grid off to infinity, we would see that this pattern would continue. It would just oscillate between -3 and 1. Okay. So let's go ahead and define what the period of this function is. Now, the period is how long the function goes until it repeats. So let's take a look at this function. If we were to look at x equals 0, our function value is 1. So how long does it go until it repeats? It gets back to 1. So we see that it goes down to -3, goes back up to 1, but it hasn't repeated itself yet. Notice that at x equals 0 is where it begins to decrease. And it's not until we hit x equals 5 that we see that starting point again, where it begins to decrease immediately after that. So we see that from x equals 0 to x equals 5, the function is defined, and for every interval of 5 after that, the function repeats itself exactly. Okay? So then the period of this function would be 5. Every 5 units, this function repeats itself. So let's go ahead and fill in the table of values. At x equals 0, our function value is 1. At x equals 1, our function value is -3. At x equals 2, it's -3. At x equals 3, our function value is back up to 1. It's unchanging at 4, so it's still 1. And likewise at x equals 5. Now, this is where the function repeats itself. So we see that one full period is 5 units. It's going to repeat itself after x equals 5. So at x equals 6, we have f of x equals -3. F of 7 is -3. F of 8 goes back up to 1. F of 9 is 1. And f of 10, our last value on our grid, is also 1. Now again, this has a period of 5, so it's just going to repeat itself. So although we don't have x equals 11 and 12 on our grid, we can, based on what we know about periodic functions, we can evaluate these function values. So since it repeats itself, we know that immediately after our string of 3 ones, we're going to have 2 -3s. So right here is where the function goes back down to -3. So f of 11 is -3, and likewise so is f of 12. So because our period of this function is 5, that means that every multiple of 5 is going to have the same function value. Okay? So let's evaluate the following function values. So we have f of 18. Now we know that every multiple of 5 is going to be the start of a new period. Okay? A new cycle, rather. So we see that at x equals 0, we have 1. X equals 5, we have 1. X equals 10, we have 1. So then we would expect x equals 15 to be 1 and f of 20 to be 1. So then f of 18, which is two units before x equals 20, we can move back 2 units in our cycle and determine that function value. So we would see that f of 18 is 1. Likewise, f of 60, we know that's a multiple of 5, so that's going to be at the start of our cycle. So that's going to be at 1. The start of our cycle is 1. Now, f of -6, if we're starting at 0, x equals 0, we have our function values 1, we can expect the same in the opposite direction. So as we move 5 units to the left, so f of -5, we would expect that that is also the beginning of our cycle. Okay? So we would say that f of negative 5 is 1. So then f of negative 6, one more before that, is going to be 1 before the start of our cycle, also 1. Go ahead and pause the video and evaluate the remaining 6 function values. Unpause to check your work. All right, go ahead and check your work. Looks like for the remaining 6, the only one that is negative 3 is f of 16. All right, so let's go ahead and find the range. Remember, the range are all of the outputs that the function hits. So in this case, we have from negative 3 to positive 1. And we want to include both of those and everything in between. So we're going to have the closed interval from negative 3 to positive 1. That's the range of our function f. Let's go ahead and talk about the transformations. So using what we know from our transformations section last unit, we're going to sketch a graph of our new function. All right. So we see that y equals 1/3 f of x. This would be a vertical compression by a factor of 1/3. So we're going to take all of our outputs from f and we're going to compress them by a factor of 1/3. Okay. So if our function value at x equals 0 is 1, then our new function is going to have a function value of 1/3 at 0. At x equals 1, our original has function value negative 3, but a third of that is going to be negative 1. The same goes for x equals 2. And then after that, we go back up. So instead of going back up to 1, we're going to go back up to 1/3. And that continues for the following 2x values. And this pattern continues. So this is our entire period, and this repeats itself every 5 units. So it's going to go back down to negative 1, and then back up to positive 1/3. Now I just drew the positive values, positive x values. We can also draw on the negative x values. So before x equals 0, the function is at 1/3. So we see we have the exact same graph, but it's compressed by a factor of 1/3. Our period hasn't changed, so notice this transformation that affects the output does not change our period. Our period is still 5. Every 5 units, it repeats itself. But our range, however, is affected by this transformation. We have that our range is from negative 1 to positive 1/3. Again, the closed interval. All right. The next transformation, we have y equals negative f of x. This is a reflection over the x-axis. So it's taking all of our function outputs and making them opposite signs. So all of our negative 3's are going to be positive 3, and all of our positive 1's are going to be negative 1. Okay, so at x equals 0, instead of positive 1, we have negative 1. At x equals 1, instead of negative 3, we have positive 3. At x equals 3, we have negative 1. And then our function repeats. So this is one cycle here, and then everything after that, it repeats. So we're going to go ahead and draw the same thing, repeating after x equals 5, because this function is periodic. Okay, so we see that we have the exact same graph, but it's flipped over the x-axis. Our period, again, is unchanged by this transformation. Period is still 5. And our range, now our range is affected, so we have from negative 1 to positive 3. Again, the closed interval. All right, let's take a look at a few more transformations. Go ahead and flip the page. For this next part, I've gone ahead and put function f at the top so that we can go back and reference that. For letter C, we've got a vertical shift up 2 units. We see that by the +2 tacked on at the end here. So this transformation is a vertical shift up 2 units. So we're going to take our whole function f and we're going to shift it up 2 units. So all of our 1's become 3's, all of our negative 3's become negative 1's. So we're going to shift it up 2 units. We start at x equals 0 at 3, and then it goes down at x equals 1 to negative 1, and then it goes back up to 3. So go ahead and draw in that graph. And this is one cycle. So it goes down and then back up. And then it repeats itself. So from here, we're going to go back down to negative 1 and then back up to positive 3. All right. So the period hasn't changed. It's still 5 units. It repeats every 5 units. The range is going to be from negative 1 to positive 3. Again, the closed interval. So notice after those first 3 examples, the only transformations that affect the range of a periodic function are a vertical stretch or compression, a vertical shift, or a reflection over the x-axis. Let's go ahead and take a look at letter D. Here we have f of 1/2 x. This would be represented as a horizontal stretch. By a factor of 2. So we're going to take all of our inputs and it's going to stretch our graph out horizontally. Okay, so we're going to still start at the same spot. We're going to start at 1. And then we're going to go down to negative 3. But instead of taking 1 unit to go down to negative 3, it's going to take 2 units to go down to negative 3. So instead of x equals 1 being negative 3, it's going to be f of 2 is negative 3. It's going to take twice as much. We're stretching that out. Also, for this interval here, we have that it's negative 3 for 1 unit. If we're stretching it, it's going to be negative 1 for 2 units. And likewise, going back up to positive 1, it's going to be instead of a width 1 unit, it's going to be a width 2 units. So that would be a horizontal stretch. And then again, we stay at 1 for 2 units, but in this case, we're going to stay at 1 for 4 units. We're stretching it by a factor of 2. So notice that our graph, we stretch it out. So in this case here, we only see 1 period in 10 units. 1 cycle in 10 units. So our period is 10. Our range doesn't change, however. So our range is still from negative 3 to positive 1. Let's try one more together, and then you'll try a few on your own. Next, we have f of x plus 5. This would be a horizontal shift. Left 5 units. So we're taking our function f, and we're going to shift the whole thing left 5 units. Okay, so how does that change our graph? Well, let's take a look. So that means that everything that is at x equals 5 would now be shifted 5 units left, and that will be our x equals 0. Okay, so if at x equals 5 on f, f of x plus 5 at 0 would be 1. Okay, so we're taking our entire cycle and we're shifting it left 5 units. Well, our original period is 5 units, so shifting it left 5 is just going to shift it over itself. We're actually going to have the exact same function here. So then it goes down, hits negative 3, it goes back up to 1, and it stays at 1 for a little bit, and then it repeats itself. So this would be this part of our function f shifted 5 units to the left. We find that it lands exactly on itself again because our period is 5. Okay, so it goes down again. It's just another repeat. Goes back up and hits 1. So a horizontal shift 5 units to the left. Because our period is still 5, it lies right on top of itself. All right. Our range, again, also doesn't change. We have from -3 to 1. Go ahead and try F, G, and H on your own. Write out the transformation, sketch your graph, and identify the period and the range. Pause the video and then unpause to check your work. Okay, go ahead and check your work. A couple things to note. A horizontal shift to the right unit, 5 units, or a horizontal shift to the left, 5 units. Because our period is 5, that does not change the graph. We're just shifting our first cycle over, and it's overlaying our original function f. Likewise, a horizontal shift to the right 2 units and a horizontal shift to the left 3 units have identical graphs because our period is 5. Okay, notice that our horizontal shifts do not affect the period or the range. However, a horizontal stretch or compression, as we see in letter D, does affect the period anyway. All right, go ahead and flip the page. We got a few more examples. Let's go ahead and try a few of these. We want to determine whether or not they are periodic, and if they are, then determine the period. Well, let's take a look at letter A. Here we have that it starts at 0, goes up, back down, up, and it seems to continue that pattern forever in both directions. It's identical for the interval from 0 to 2. It just goes up and back down. So this is periodic. And its period, it looks like it, how long does the function take to repeat itself? Looks like 2 units. After 2 units, it begins repeating. Letter B, well, it looks like we have that harmonic motion here, but it does not have exactly the same thing for a given interval. Looks like the size of the waves are getting smaller as we move out. So because it's not exactly the same thing for a given interval, this is not periodic. Letter C, it looks like we start at 0, we go up, and then we've got this wave pattern. But take a look at what's going on at 0. We've got this cusp. I don't see this cusp occurring anywhere else in the domain of our function. It only occurs at 0. So because it's not exactly the same for any given interval for the domain of f, then this is not periodic. And last but not least, we've got this graph here. Let's take a look at what's going on here. Well, if we start at 0, it goes up. We've got like these double peaks, go down, another peak, a minimum, then it comes back up, and it hits our 0 again right here. So it looks like it's repeating itself between this interval. It goes up, double peak, another peak, a minimum, and it just continues, and it repeats itself for all x in the domain. So then this is periodic because it's exactly the same thing for a given interval. It just repeats itself over and over and over. So then the period of this is going to be from 0 to, looks like right in the middle of 2 and 4, so that would be 3. So this has a period of 3. Let's go ahead and graph the following functions in our graphing calculator and determine the same thing, whether or not they're periodic or not periodic. And if they are periodic, determine the period. So go ahead and pull out your calculator. This first one, we have the absolute value of the sine of x. So let's go ahead and graph that. We have the absolute value of the sine of x, and I'm in radians mode. We see that these are the positive values. This is the sine function. So we see that the function just kind of bounces above the x-axis. In fact, we have the same motion for all x in the domain. We have this defined interval, and it repeats itself over and over and over. So this is periodic, where the period looks like this is a little after 3, and exactly this is pi, actually. So it repeats itself every pi units. So this is periodic, and its period is pi. Let's take a look at the sine of the absolute value of x. So let's plug that in our calculator. So we have the sine of the absolute value of x. Let's take a look at that. So we've got this motion here. In fact, this looks very similar to letter C in number 1. So because we have this cusp at 0, it's not the exact same for all x in the domain. So this is not periodic. Y equals 2 to the cosine of x. Let's check that one out. So 2 to the cosine of x. And we've got, again, kind of like this wave motion here. So this does repeat itself. Looks like it starts up here at 0, and then it repeats all the way up right here. So right here, this is a little after 6. This would be 2 pi. So this is periodic. And its period is 2 pi. Y equals the cosine of the sine of x. So we have the cosine of the sine of x. And we also get these little waves here. So it looks like we have from 0 to a little after 3. Again, this is pi. So our period here in this case is pi radians. And last but not least, we have y equals the cosine of x squared. And we've got this here. And it looks like, though it has this harmonic wave pattern here, it's not the same for any defined interval. It does not repeat itself over the same interval. So this is not periodic. All right. Let's try one more example. Let's go ahead and construct our own periodic function. So the criteria that we have to meet, it has to contain the point 0.03, the period is 6, amplitude is 4, and the maximum is 5 at x equals 2. Before we draw this, let's go ahead and define what amplitude is. Amplitude is the height of the function from the midline. It's the height of the function from the midline. So we'll see how that looks in the graph. But let's go ahead and identify the other three criteria. So we have that it contains the point 0.03. So that point is going to be right here. That's our y-intercept. Our period is 6, so that means it's going to repeat itself every 6 units. So then 6 units after 0, it's also going to be 3. So 1, 2, 3, 4, 5, 6. That's also going to be 3. 6 after that, it's also going to be 3 again. So 1, 2, 3, 4, 5, 6 right here. It's going to be 3 again. The same is true for the other direction. It's going to repeat itself in the other direction. 1, 2, 3, 4, 5, 6. That's going to be 3. We've also got that the maximum is 5 at x equals 2. So at x equals 2, we've got a maximum of 5. And then it repeats itself, so it's going to have another maximum right here. If the graph continued, it would be another here. And there would be another here. Again, this is periodic. It's going to repeat itself. Now we've got that the amplitude is 4, so we're saying that the height from the midline is going to be 4. So if the maximum is 5, that would mean that our midline is 4 below that at x equals, or at y equals 1. So I'm just going to draw a dotted line. That's our midline. So then the amplitude means that we also have a minimum of 4 below that midline. So a maximum 4 above and a minimum 4 below. So you can choose any point. I'm just going to choose halfway between these points. So I'm going to say like right here. Okay. Because it's periodic, it's going to occur 6 units later and 6 units before. So we've got just a series of points here. Let's go ahead and connect the dots. So if we start at 0.3, it's going to go up, hit a maximum, and then it's going to come down real quick and hit a minimum. And we come back up and we hit our starting point again. So this is going to be one cycle, and it's just going to repeat itself on either side over and over and over. It's going to come up, hit a maximum, come back down, hit a minimum, and back up. And I'm just going to draw arrowheads on the end here to show that it continues off in that direction. So I'll just go ahead and draw one more cycle to the left. And again, I want to include that arrowhead on the left-hand side because it continues in that direction as well. Okay? So double checking, we have the point 0.03. We have a period of 6. It repeats every 6 units. We have an amplitude of 4, so our max is going to be 4 above the midline, and our min is going to be 4 below the midline. We have a maximum at 5 at x equals 2. And we have that here. All right? In summary, periodic functions are functions that repeat themselves over and over and over for all x in the domain. All right, we're going to get a whole lot of practice on this. We'll see you tomorrow in class. Have a great day, everyone.